So my name is Yingkun Li. I'm currently a visitor at the MPI in Bonn, supported by the Heisenberg Fellowship. And before that, I was a junior professor at TU Darmstadt from 2018 to 2024. And before that, I was a postdoc also at TU Darmstadt for 4 years. And that's after I got my PhD in UCLA, which was from 2009 to 2013 under the supervision of Bill Duke. And before that, I was an undergraduate at Caltech for 4 years, studying mathematics. And starting in the fall of 2025, I'll be an assistant professor at UW Medicine. The area that I work in is number theory. In particular, I study functions called modular forms. So these are functions that have a lot of symmetry and has a very long history, maybe over 200 years. People have already studied them, and they have very interesting properties, probably mostly seen in number theory, but also in other areas of mathematics. For example, because of their symmetries, which includes periodicity, they have Fourier coefficients, and most of the time these are integers, and people like to study their properties. And I also studied those in my areas and in my research, and and sometimes they are not integers but other interesting number theory qualities. I guess there are maybe too many, but let me just share one, which I think was kind of interesting. This happened on a train trip with another colleague. So we are discussing our research joint project, studying Fourier coefficients of modular forms and their divisibilities. And this happens to appear in a paper studied by physicists, something about the Hall effect of magnetic plates. So we decided to call these modular forms magnetic modular forms. And while we were discussing on the train, I think maybe we were a bit loud, and another passenger came to us, and we thought that he would just maybe ask us to be a bit quiet, but then he got very interested and he said, I heard you guys were talking about something magnetic. Is it something related to physics? And we were quite surprised, and it turns out that this person had some background, maybe in university studying physics, and then he's always been interested, so we try to explain what we are doing and how they are related. I think that was pretty interesting. Oh yeah, there are lots of them. I think maybe the first one was when I was writing my thesis or working on my thesis. My advisor gave me a problem which I have to first understand, and after that I have to try to compute some things using computers, some Fourier coefficients using computers. And it's just numerical computations. So basically you get an expansion where the coefficients are some real numbers, some floating point digits, and then you try to recognize if there's some pattern. And I remember I was doing just computer calculations for maybe 3 weeks. I got lots of data, but then I couldn't see the pattern in there. And then I think one afternoon I just got really tired working in the computer lab. And at that time, the computer lab is also in the basement, so there was no window. So I decided to go out for some fresh air. And then when I went out, and I was feeling quite frustrated. And then so I prayed to God that if this is something that you created, if there's some beauty in this, please let me see it, so then I know that you have created it. And then after that, I went back to the lab. I had my old data, and then somehow before I thought they were just some junk data, and I tried to plug them back again into the calculation, and then something miraculous appeared. I can see some pattern now. And I showed this to my advisor, and he was also very excited. And then I think maybe just 2 weeks later, we figured out more or less what was happening. And then it took another maybe half a year to like get a proof of a result, which was more or less the basis of my thesis and the joint paper with my advisor. So that was a very cool moment. Yeah. I probably would like to be a medical doctor. So, and unfortunately that didn't happen, although I think my parents would be very happy since my mom is a nurse and she would like very much that I become a medical doctor. But then I think it was sometime in 7th grade we had to dissect a frog, and it was another nice experience for me. And I think we also had to dissect pigeons. They're also not so nice. I didn't find it so nice, and also when I see blood, then I get dizzy. So that's probably a sign that I cannot be a medical doctor, at least not in this universe. I like to play guitar, and then like to play sports like basketball. But now with less time because of work and family, then maybe just watch some basketball. Yeah, I like to spend time with my family, with my wife and 2 kids. Also on Sundays we like to go to church together. I think mathematics is a very special area, and then it's something that I think everybody could learn something from it. And if you want to pursue it, it would take some talent, but then it would take a lot more effort than people realize. So what I found is that actually for people, maybe this is advice to be careful that if you're very talented then or very good at math, then when you're pursuing math research as a career, then you should also be careful, because somehow this is also somewhat from personal experience. When one is maybe younger, like before university, and maybe one's somehow good at math, but then that level, that type of mathematics is different from what one learns in the university, and then it's also different from what one does research in. So it's actually, I find it's a process that somehow if people are more talented, then when they are younger or when they see these math problems before universities, then they can solve it rather quickly, and then of course you feel very rewarding once you do that. But in math research, the result don't usually come so quickly. One has to spend a lot of time thinking about the problem and working out details before one sees some kind of pattern or make some kind of progress. So one has to be patient when doing math research, and this is quite different from, say, even studying university mathematics, where you do your homework and then you do your exam, and then you have to finish these problems within a set amount of time, and you know that there's always going to be an answer. And whereas in math research, it's really unknown that one explores. Otherwise, there is no fun in that. So I think one has to be patient in doing mathematics. Besides being patient, another quality that's important in doing mathematics is to be optimistic. So I remember when my first research experience was as an undergraduate, and my advisor at the time, he gave me, or we found a problem together. We found a problem together, and then I tried to work on it. It was a summer project, and the length of the project was 6 weeks. I remember for the first 4 weeks, I was trying to just understand what the problem was saying. Okay, and finally, when I was able to understand what the problem is asking, and then the last 1 or 2 weeks, I tried to get some result, and I realized that it's really difficult. So I remember maybe one evening I just got really frustrated. I thought this is just very difficult, but then maybe one cannot get the nice result that you want. But one can still get something that's beyond what people had done before. And I realized that sometimes you cannot get the perfect answer in just the first try, but you can get something out of it. Besides learning new mathematics, I also get to prove some cases of some theorem that people have maybe not looked at before. It's nothing significant, but I think it's still a contribution to the development of this area. Right, so then I think this is also an important quality that I'm still trying to learn, which is to be optimistic that it takes time to get the perfect result, and one has to do it step by step, and one should always be encouraged that we are making some progress today, instead of saying we try to make a giant leap today, because you never know when that idea will come. It could be it could very likely that the idea comes when you're not thinking about the problem, because our brain works in a very amazing way that even if we are not thinking about problems, it's still somehow in the background doing some kind of, computation or some kind of logic deduction. Yes, so being optimistic, I think it's another important quality. I think I have two more qualities that I think would be quite good to have. Something that I didn't realize before was that doing mathematics actually is something that should be done in a social environment. I think this is contrary to what people have in mind when they think of people doing research in mathematics, that they probably just lock themselves in a room with their stacks of papers and maybe a computer and just work day and night, and then basically fill out the waste paper bin. And I think that's maybe some people work like this, but I think also it's important that one not just works by themselves or think by themselves, but actually talk to other people. So I don't know, maybe if this is a suitable analogy, like doing math research is it's a process of exploration. So like, I don't know, in the old days when people don't have satellites, then you have to measure the earth, then you have to go sail to the sea, and that's some kind of exploration. And doing math is somehow like that. And when you're starting as a grad student, maybe you are working on some ship captained by somebody, and then once you get enough experience, you get your own ship, and then you go sail. So I think it's important that you also talk to other captains or people from other ships to see, if they have seen anything like interesting, or if they have seen something dangerous that you should try to avoid. And so I think it's quite a social activity that when you talk to other mathematicians or just other people doing mathematics, research in mathematics, then you can see how they think, and then you can also bounce off ideas of each other. And I think that's very valuable, and actually a lot of times I found that very helpful, and I think and the MPI also provides a wonderful environment for that. At least there's a tea every day where you get to meet people, and then you can also go knock on people's doors and then just talk to them, or just in the hallway. And I think that's very stimulating for thinking of mathematics. Yes. Okay, and I think there's one last quality. Yes, and I think the last quality which I'm still trying to learn is when one's doing mathematics, one also has to learn to get out of one's comfort zone and be bold. And yes, I think maybe that's true for a lot of careers, but I think for mathematics, and in particular, it's also true, I think, for mathematics. So by that, I just mean that when you just completed your first research problem or your PhD thesis, then you're familiar with one area of mathematics or certain types of problems, and you know certain techniques that works very well. And now maybe it's then quite tempting to just try to see what I can do further in this area with this technique. And I think that's very natural. You want to explore the boundary, the limitations of what you can do. But after a while, you'll see that within this same area, you're kind of have figured out or exhausted all the possibilities, or you have thought about different possibilities. Maybe you have proved some results, maybe not. But maybe the source of inspiration is drying up here. So that's when you should try to look somewhere else and to see if there's something else interesting. And so you could talk to other mathematicians or just attend some seminars that might not be entirely in your area. And then, but still, there should be some connection. And then try to see if something clicks. And I also found that useful that when I attend talks, that's not entirely about what I do. I can still try to understand what they are doing and see what I did could be related to what they are doing or what they have in mind. Yes, and so one has to do that, and then one can make a good explorer. I think the MPI it provides a very stimulating environment, as I said, for doing mathematical research. So there are lots of seminars, and also every week there is over seminar, the colloquium, where people introduce their research. There's the number 3 lunch seminar, where people not just go to talks, but then also have lunch together. It's very social. And there's also the tea every day that people can go to, and then maybe talk to someone there. But otherwise, one can just look up who's visiting or who's there, and then just either send an email, make an appointment, or just knock on the door and talk to the person. I think that's very nice. And also, I think most people here don't have to do teaching, except maybe some postdocs where they can choose to teach. So then one has really a lot of time that one can devote to math research. So I think that's very nice.